A pump curve is a graph or chart that we use to size or determine the flow rate of our circulators. These curves are specific to each circulator and provided by the pump manufacturer. Pump curves can be intimidating due to the amount of information they display, but understanding and using these curves is actually very simple. We know circulators flow water by creating a pressure differential or delta P. We can convert this PSI reading into feet of head, which is represented by a vertical line on the side of the chart. The bottom line of the curve represents flow. In this case, it's listed as gallons per minute. And then there's the curve itself. The curve represents the maximum potential of the impeller and runs from left to right, in this case from the pressure side of the curve and sloping down toward the flow line at the bottom of the chart. The left side of the flow line represents zero flow and increases as we move to the right. Our impeller line enters the chart at zero flow and represents the maximum pressure the circulator can generate at this point. In this example, the impeller cannot flow water at 29 feet of head or higher. And as the curve moves away from the headline, it represents the flow rate as the head pressure is reduced. All we have to do is draw a line from the headline until it intersects the impeller curve. Then draw a straight line down. Our flow rate is revealed where our line crosses the flow line. And as you can see, as the head pressure applied to the circulator is reduced, the flow is increased until we reach the end of the curve. The end of the curve represents the absolute maximum flow the circulator can achieve, but the maximum flow is generally not our desired outcome. We also have to make note of the efficiency lines on the curve. The first law of thermodynamics teaches us that energy cannot be destroyed, it can only be converted to something else. The energy we put into the circulator is converted to flow, but if we deadhead the circulator by placing too much pressure against the impeller, or pump off the curve by not having enough pressure on the circulator, this energy is instead converted to heat and the motor may fail prematurely. We use the efficiency curves to determine how much of the energy we're putting into the circulator is being converted to flow. Our desire is to select a circulator that intersects our impeller curve at the highest efficiency possible. This is generally in the middle or knee of the curve as it begins to drop down toward the flow line. We can even plot a system curve based on the different flow rates and pressure differentials as changes are applied to the system. Are you attempting to use a single circulator for all of your zones? Well, as zones open and close, the head pressure affecting the circulator changes, and therefore the flow rate of the circulator changes with it. Some pump curves even have more than one impeller line. These could represent different sized impellers, different circulator speeds, or even different circulators if the manufacturer is combining curves together for a quick reference. Thank you for watching.